Okay, so let's start to apply the method of joints to an idea of an actual bridge itself. Okay, so you can see here I've added in another one here. We've got to take the moments, but let's just step through this. The first thing we've got to do is try to understand the forces and their reactions within these beams. I know I have a force going up here, and it'll be the same on this side here. So as this force is pushing up, this is going to be pulling away from the joint. It's going to be going in this direction here, which means that the joint is in tension, so this member is going to be in compression. Okay? Here we've got another 90 going this way, so obviously we're going to have this coming back this way away from the B, so again this is going to be in compression. Force coming up, pushing out this way, again it's actually going to be in compression itself. Okay, so you can start to see here, like with these joints, I'm starting to work it out how the actual movement is within this diagram. Now you've got to think about this logically. I'm pushing up here, it's pushing up there. If nothing here is actually working on this joint itself, going in the opposite direction, this will all just start to pop. So this component here is actually in tension, which means it's the same on the other side because we've got it balanced. This one here will be in tension as well. The final one, because we've got this running all the way along here, we're going to find that this middle joint itself is also in tension. Okay, so we've got those ones working that way. So that leaves us with these three joints here. Again, looking at how this is working. We've got pressure coming up this way. We've got pressure coming along here. So again, we're wanting the reverse to actually occur on this joint to support it. So in this case, it's actually going to be pulling away from there just to hold this down. If not, this is going to pop up. Okay, so to hold that down, that means that that's going to be in tension, and this one will be in tension as well, as it's a balanced bridge. Okay, so tension, you can see it's got the two arrows in the center, and compression has the arrows the other way. Now this final member here, if we just start to have a look at it, we've got this force traveling this way, and it's going to start to be pushing down this way as well. So we're going to find that this will be traveling away from the B, which makes that this one here is going to be in compression as well. I like doing this at the beginning because, like I said, it starts to focus what I'm actually looking at in this bridge. I'm seeing where the sensors are, and that's half the questions actually answered. Okay, so it's just a nice little way to start these, just to start thinking about the bridges. Now you can see here, we've still got to work out the moments. So what I'm going to do, I'm going to ask you to actually stop this video now, and then work out do the equation for the moments around the pin to work out what A is, this force here, and then sum the forces at D vertically and horizontally to work out what those forces there are. Okay, so stop the video now and see if you can work out what these forces are here. Okay, so let's have a look here. What we actually want is we want to actually sum the moments sum of the moments, and I'm going to say, all right, anything that is going to go this way is going to be positive, and it must equal 0. Therefore, 0 equals. So I'm now just doing the equation. Like I said, I can see my first one is, like if I'm looking at A and it's spinning around. So here in D, where am I D? Oh, no, it was the wrong place. So around D, I'm saying it's going to be spinning anti-clockwise. So you can see A is going to be plus A, because it's actually going in a, oh, sorry, no, it's not, it's going to be a minus A. Look, nearly got that one wrong. So you can see you've got to actually keep checking. You've got to keep checking yourself to make sure it's going the right way. A will actually turn it anti-clockwise, so we've got minus bracket A by, and I can see there's 2, 4, 6 intervals there. I've then got a 60 kilonewtons, and that will actually spin the item anti-clockwise. And that's what we want. So that's plus bracket 60 kilonewtons by 4. Now there's one more force that we've actually got here, and it's the 90. So if you can imagine, if that force is going in that direction, the object will spin around D in an anti-clockwise method. So basically we've got plus 90. Now the trick here is to work the distance out. The distance itself is basically between, oh, you can't quite see it. I'm just trying to do that. Let me just do it with this one here. Here I can actually go, let me click this on, right. So this is the distance that we're actually talking about. And so from our drawing, we can see that that is actually 1. This force line goes all the way along. It travels all the way along, okay? So it's this distance that we're actually looking for. So it's 90 by 1. So then we've got now A by 6 equals 240 plus 90. So A will equal 330 divided by 6, which equals 330 divided by 6 equals, oh, I'm just trying to see my calculator here in the dark, 55 kilonewtons, and it is going directly up. Okay, so now I've got my first part, I can start to look at the second part here, which is the summing of all forces. So if I actually want to do the horizontal ones first, I'm going to come over here, I'm going to go, oh, so the sum of all forces horizontally being plus must equal 0. I now know that I've got, I have a force that is D, and it is minus a force of 90 kilonewtons, which is going back in the opposite direction. So minus D equals minus 90, they cancel out. So D equals 90 kilonewtons going in this direction. The other force I actually want, I want the sum of the forces that are going up being positive must equal 0, therefore 0 equals. So now I can see my forces. I've actually got 55, I have a minus of 60, and then I've got a plus of D. So then minus D equals minus 5, they cancel out. So D equals 5 kilonewtons. Travelling straight up. Okay, so now that we've actually got that, we're just going to fill those in on our document so we know what we're actually looking at before doing some calculations. So you can see here, I've just come in and I've substituted the forces from the calculations in there. so we know where we're actually standing. So the next part of this now is to actually do our free body diagrams for each of the calculations that we're going to be doing. Okay, so let's have a look at joint A. So for joint A, I'm just going to do my free body diagram here for that. Okay, I'm going to have my A, which is my joint. That's A. I'm going to have 55 kilonewtons coming up this way. I actually have a B going this way. So this is B. And I've then got an E coming back this way. Okay, so you can see by starting to calculate out those joints in the very beginning, it's quite easy to now start to get these directions in here. All right? So there's a couple of things that we're still missing here, and you've got to start thinking. First thing is, what is this angle? Okay, we need to actually know what that angle is, okay, before we can start doing any more calculations. Like I said, if you've got more than two unknowns, we can't work it. So we're trying to reduce that. I want you to stop the video now and see if you can actually work out what that angle is. Okay, so I'm hoping that you've actually had a think about this and try and again problem solve it. And I am just coming back to my trig stuff here of SOHCAHTOA. Oh, SOHCAHTOA. So here I can actually see tan angle equals adjacent. Opposite over adjacent. So in this case here, I know that tan angle equals my opposite. If I come back to my drawing, I know that this is 2 meters long. This is going to be 1 meter long if I actually draw this in. So I actually have opposite 1 over 2. So angle equals 0.5 inverse tan, which equals oh, I'm just going to get rid of myself a little bit there. 26.56 degrees, which will bring it down to just 26.6 degrees, okay? So now that we actually know that that's the angle, we can start to do some of the equations. This now we can get rid of. And we know that that is 26.6 degrees. I'm going to get rid of this detail because we don't need that anymore, and that will only confuse us. And I'll just get rid of that there. Okay, so the next thing I need to do is start to form up my force polygon. I know it actually runs in here. All right, and this is going to be AB. This is going to be AB vertical, and this is going to be AB horizontal. There is my angle going this way, so my resultant forces are going this way. So, here we go again, just calculating it out. So, sine angle equals opposite over hypotenuse, which will then give us hypotenuse sine angle will equal opposite. So now AB sine 26.6 will equal AB vertical, which is what we want to do, separate it into our verticals and horizontals. Cos angle equals adjacent over hypotenuse. H cos angle equals adjacent. So AB, excuse me, cos 26.6 degrees will equal AB horizontal. Okay, so I'm just going to underline these ones because we're going to use this one and we're going to use this one to get this equation out. Okay, I want you to stop the video now and see if you can actually work out what AB is, and then also sum the forces to find out what member AE is, okay? So we're looking at two different ones, AB and AE. Give it a go and see if you can actually work it out from here, what the actual equation is and what the answer is. Okay, so I've given you, hopefully you stopped the video and you've done this equation so you can work it out. Let's give it a go here now. So, for AB, okay, again we want to actually sum all the forces. Sum of forces going vertical being positive must equal 0. Therefore 0 equals. Now I'm summing all the forces. I can actually see I've got 55 because that's the force going directly up at the roller. Right. I don't have one at AE because that is a horizontal, it's not a vertical. So I now have my B vertical, which is in this case it's also going up. Yep. Plus AB sine 26.6. Okay, so they're the only ones that we've actually got. So minus AB sine 26.6 equals 55. Minus AB equals 55 over sine 26.6, which equals 123 kilonewtons. Now, you can see here, I've got the sense wrong. Okay, and that's okay. All it means is that here it is the opposite of this one. Right. So that means that this direction is coming down, and again, we've already worked out that this is in compression. Okay, so we've already worked out that that member's in compression, but we've actually seen that the force is coming down on that joint. Okay, that's what we're looking at there. So now we're looking at solving E. So for AE, right, we were looking at the sum of all forces this way for horizontal plus must equal 0. Therefore, 0 equals. I'm just trying to work that out. Yep. Okay, 0 equals AE. And we're actually saying that AE in this case is going the opposite way, so it's minus. Then we've got a plus for AB. So AB cos 26.6 degrees. So AE equals, now AB we've already worked out, it's down here at 123. 123 cos 26.6 degrees, which equals 110 kilonewtons. and we're going in this direction. And we know from our earlier discussions that this is in tension. So you can see what we're doing here. We're actually working our way around each of these triangles, okay, and finding out what the actual answers are. Right. I'll fill those answers in, and then we'll just break down the next joint for you to give it a go. Okay, so you can see here that I've filled these in. AB is 123 kilonewtons and AE is 110. So again, coming back to what we actually say we need to do. The first thing that we want to do in this case is draw our free body diagram. Now let's just keep moving around. So we're going to go to B now. So if I've actually got B, where's that dot there? Let me just come a bit higher. Okay, so I've got B here. I now got one force this way, and it is actually at 90 kilonewtons. I've got one force coming this way, and it's at 123 kilonewtons. I have a force down. It's actually compressing back on this joint. And I have a joint this way as well. Okay, so this one here is BE, that's E, that's B, and this here is C. So you can see here I'm only, oh, and we've actually got one more joint in here as well, which is coming this way. It's coming down, and this one here is F. Okay, so you can see that there's lots happening here. Lots happening here. Now just looking at our diagram, I haven't accounted for the 60 kilonewton force, which is on this here. Right? And I know that this force is actually pulling down in this direction. Okay, so while the member may be in tension, we actually do have that 60 kilonewton force acting upon it, which we can't ignore. Okay? What I want you to do now, I actually just want you to sit back and just fill in these. We're looking at the different steps. We know that here, AB and BF need to be converted into these force polygons to be able to calculate them out. Okay, once we've got those two, and we've solved that unknown of F, then we can come back and solve C. Okay, so what I want you to do, I'm just going to leave it there for a second, and I want you to stop this video and see now, based on your past experience, break down what this one is and what this one is, so we can have a look and see what we're actually doing. Right, so I'm hoping that with this you've actually come along and you've started to break these down into its horizontal and verticals. Okay, once we do that, then we can start attempting the math itself. All right, so again, here's my first force polygon. All right, and I know that this is 1, 2, 3. This one here is AB vertical, AB horizontal, and I know that this force is going in this direction. So I've got this one coming up, I've got this one going across. Right, and I'm using Circuitar to break it down. So again here, I know that my angle previously was 26.6 degrees. And that hasn't changed. Okay, breaking this down here, I know that I've got 1, 2, 3 sine, sine 26.6 degrees will equal ABV. 123 cos 26.6 degrees equals ABH. Now my second one, and again I've cut some steps out here just to keep it moving, and I'm hoping that you can see what I've done here. So my second force triangle I've got is this one. This one here is BF, and down here I'm going to have BF horizontal, BF vertical. Okay, so again here, this angle is going to be the same. I can see the triangle is the same. So this one here is going to be 26.6 degrees. So here, BF sine angle will equal BF vertical. BF cos angle, which is 26.6 degrees, will equal BF horizontal. Let me just change that because I know that is 26.6 degrees as well. So now that I've actually got these all in place, I've actually got my horizontals and verticals, I can now start to do the equation. Okay. So here, what I'm actually looking for is the horizontals and verticals, and I'm working around that idea of the BF. Okay, so let's go. Let's do BF then. The sum of all forces, and in this case we're going to do BF. Yep, we'll do BF vertical as plus must equal 0. Therefore, 0 equals. Let's start going around it here. No vertical force here, so I don't have to worry about that. Here, my vertical force will be, and I can see that this one is going to be going up. So it's a plus, plus. 1, 2, 3, 1, 2, 3, sine 26.6 degrees. My next one is coming down, so it's minus 60. My next force is also coming down, so going that way and that way to get to there. So it is also minus BF sine 26.6 degrees. BF sine 26.6 degrees equals, let me just work this out on my calculator. Okay, so what I just did then, I just paused the video and filled it in. So I've got BF sine 26.6 equals 55.07 minus 60, comes down to BF equals minus 4.9 over 26.6 degrees, which equals 11 kilonewtons, and you can see here I got the sense wrong. Because I've actually got this sense wrong here, it means it needs to go in the opposite direction to what I actually had it. Okay, so you can see that that's what's happening there. Oh, actually, no, hang on, my mistake. So it's actually down, that's minus, so that should be the right way. Coming down. Right. Okay. Now I can actually do C. The sum of all forces horizontal plus must equal 0. Therefore 0 equals. Now again we're looking at the horizontals. I have minus 90. Right? I have again here I have for AB. Let me have a quick look here. I've got that one there. Right. Minus, no, that's a plus. Plus 1, 2, 3 cos 26.6 degrees. And then I've got another plus here. Got a plus here again, so it's going in the right direction. Got 11 cos 26.6 degrees. And then the final thing I've actually got to get on there is my plus C. So minus C equals minus 90 plus. Okay, so I just filled that in for us again. Sorry for the little breaks that are occurring. But you can see here, minus 90 plus 1, 2, 3 cos 26.6 plus 11 cos 26.6 by, sorry, this should be BC. Right. So again, minus 90, again just working through it here, minus 90 plus 109, so I've converted these to numbers already, plus 9.03 equals 29.82. I've got the cents wrong, okay, so because I've got this cents wrong here, it means I've got to go into the opposite direction. So it's coming back onto the joint and it's in compression. Okay, so we've got the compression here because we worked that out earlier, but it's coming onto the joint rather than pulling away. Okay, so again here, if I was to draw this in compression, it's coming that way and that way. Okay, so that's for the joint itself, so it makes a bit more sense that way. Look, I'm going to leave that with you now to work through and see if you can actually do the other joints. We have to do joint E, we have to do joint F, C, and D. Okay, so that's a bit of homework for you. I'm hoping by now that you've actually got the process down pat, and then you can just start working through it. Like I said, with all of these here, firstly, again, find out what the sensors are in this diagram itself before you start. Work out your moments around the pin, and then sum the forces to get the other sensors or the other reactions. For each of these joints, do a free body diagram and then break it down into the horizontal and verticals so that you can understand the math that's occurring. Substitute this into your equations and then just work the math down until you actually get your solution. So give it a go. See if you can actually find out what these other joints are, and I'll give you some feedback later on about how that all went. Thanks for listening to me, and I'll talk to you soon.